I had a couple experiences just in the last couple months where I was looking at something, I was in a shop, I saw something up there, and then I was startled when it moved, that it was a video signage rather than just something statically printed there. And one time I pulled my iPhone out of my pocket and it had a room card key stuck on the top right inside the bezel. And I spent a moment staring at this going, how did this image get on my home screen? Before I realized, it's like, oh, that's a physical card placed on top of the, stuck to the screen of my phone. So we are really most of the way there with display technologies when I'm mistaking displays for reality. But there's still things that can get better on it. It's great to see some of the things like viewing angle is almost a dead issue. There's improvements that can be made in pixel fill when you get up really close. Like if you look at things under magnifiers, like in a head-mounted display, you can complain about gaps between pixels, but that gets addressed as resolution gets better and better. And displays are amazingly cheap. There was a picture of me that was in some magazine that showed me with two LCD screens, square aspect ratio, that were 1280 by 1024 many, many years ago. I paid $10,000 each for those IBM displays. And you think about for a couple $100 now gets you a good 1920 by 1080p display. That's the miracle of modern electronics, and that's a really, really good thing. About the only thing that's not going well in displays is latency, and there's a trend to more and more things that happen between the bits going in the HDMI port and pixels lighting up on the screen. Now, there's more adoption of gaming modes. Nvidia is pushing pretty hard on the manufacturers at chip level to make sure that a gaming mode does the right thing, that it feeds through directly and doesn't add latency. It's a little bit tricky when you think about things like if you're feeding a 1080p signal into a 1080p display, then it's obvious what happens. But if you're feeding in a 720p signal, then it's got to be refiltered at some level. And I mean, that's another thing that gets done wrong all the time. They're not gamma correct usually in the resampling. They may do various other filters in it. But what we need is a bit going over the data stream. And this comes into the whole, oh God, how do we corral all of these people? So we need something at the driver level. We need something at the hardware level. Then we need something on the TV that listens to this and actually does something different. But that's what we need, is anything that's generating an interactive signal, something where you're doing something and it's generating an image based on what you're doing, should be in no latency mode, no processing. Because a lot of the processing that gets done is sort of assumes an MPEG compressed stream, and games are not that, and that should be turned off, because in some cases it's generating appalling amounts of extra latency. So that's one of the things that has sort of regressed a little bit. And that happens in a lot of areas, actually, where you get bandwidth increases at the expense of latency. And sometimes clock speeds go up enough that the latency decreases in an absolute sense anyways, but we've hit limits on clock speeds in a lot of cases. So now, as we're increasing bandwidth, we're getting more latency. And there's a lot of just sloppy programming, not knowing that it's important in all the different cases. But that's something that I push hard on, and I'm hoping that there will be continued improvements in that. Resolution, where we look at phone resolutions when you're at Retina display, and Retina display, as it's termed now, doesn't mean more resolution isn't beneficial. You can still see aliasing if you look at a wireframe rendering going on a phone at a normal display distance, but it's pretty damn good. I would be, as an image processing or as an image rendering producer, I wouldn't be too sad staying at a 1080p resolution and concentrating on getting the anti-aliasing right and all that. It's nice right now, and it might be a brief window where 1080p usually does mean 1080p pixels. The 720p was not like that on hardly any displays. They were always resampling, and that was a bad thing. So I worry that more resolution, if you start getting displays that have 2.5K resolution, then those are going to be resampling all the input signals. We're going to go through all of these same problems again. There's going to be more latency added, more non-gamma correct upsampling, all sorts of problems. But it does look like the industry push for 4K is gaining momentum, and it seems almost ridiculous to me that but it's going to happen. The electronics people need something new to sell, so they're going to make 4K happen. It's not clear to me that that's going to make a huge win on people's walls and displays. The the selfish thing that it is going to be great is it's going to be good for the place where we really desperately need resolution is the head-mounted displays. When you're looking at your PC or your TV screen, resolution is pretty good. Maybe it's not everything that you'd want, but in head-mounted displays, we really do want a lot more resolution. And we're going to get it, not because the display manufacturers particularly care about that market, but because they need to have bigger numbers on it. It's the megapixels race on it. And we're going to have, it seems ludicrous, but we're going to have 4K tablets and mini tablets in not too many years. And that'll make just a dandy head-mounted display for that. So there's going to be some value coming out of it, but I think that is kind of going beyond the knee of the curve in benefits to consumers again. Refresh rate is something that there's room for improvement there. A lot of displays now do 120 hertz internally for 3D shutter glasses, but very few of the consumer devices take it as an input. And even a lot of PC monitors, you have to hook it up with just the right cable and enable it just the right way. But a 120 hertz display is noticeably nicer. It's not going to change the way you look at things or make your jaw hang open in astonishment, but it's nicer and smoother, and it affects everything. Everything on your desktop is better with, at 120 hertz. So there's room for hoping that goes. And in our limited bandwidth budget, I'm afraid that it's going to come down to more resolution, where doubling the resolution versus doubling the frame rate. At this point, I would take doubling the frame rate. At different points, there would be different trade-offs between that. But I just hope that whatever bandwidth we get, we can choose to deploy as frame rate in addition to resolution. The actual stereoscopics for shutter glass TV is still, it's not a world-beating feature. When you set it up with all the right parameters, if you have your stereoscopic screen set up with the parameters set so that it is an extension, your field of view at the distance you're sitting for that size of screen, the field of view is correct, the projection matrix is correct, and the separation for your eyes is correct, it can be a really powerful experience. You can have that sense of, I can put my hand through the screen and grab that thing there. But there's a lot of reasons why you almost never actually see those set of parameters. In fact, one of the console vendors has a limit on the maximum screen separation, which is somewhat below what you would like to put on it. And the reason it's like that is because it causes eye strain as you deal with your eyes they know how much they have to toe in to center on something, but they're focusing at a different amount. This is the vergence effect, and that is an issue with eye strain, and we generally try to minimize it by tuning it down a little bit. But you also have lots of issues with the game content that we're putting in, where if you have your monitor a certain distance from you, that would mean that in-game, if you were doing it all exactly right, you would not be able to show on screen something that's going to be closer than that, where in first-person shooters, you've got the whole issue of your weapon, which is positioned in this aesthetically pleasing orientation and field of view for two-dimensional rendering, but it's just wrong for 3D, and it's not completely clear what we want to do on there, where ideally, you would have something that, if you've got your screen out there, you want something which would only be like holding it sort of, at a distance that's not realistic. Because if you hold it normally, you can project it onto the screen, but then you've got something falling off at the edge of the monitor, and that's another eye strain-inducing thing that causes problems. So, stereoscopic stuff is not too hard to do. I think it's an excellent stepping stone towards the head-mounted displays in virtual reality, which I do think is one of those can make your jaw hang open and really make a difference effects on there. So you can pick it up sort of along the way. As a destination on its own, it's still not super awesome. Now, the one exciting thing for me that happened just in recent months is I had to reevaluate some fundamental assumptions that I had on what's important on the displays. And this is great for me because this is something that I've never talked about. I haven't talked about in the previous talking about displays, but the issue of persistence and judder, where Michael Abrash's team at Valve has been pushing hard on this. And the first time I went and talked with them about it, I was really skeptical, where I'm like, no, I want a 120 hertz display. That'll fix the problems that we have with 120 hertz OLEDs, problem solved. That was my position. But they went and they've built some test hardware, and the best way to win an argument is to build hardware and prove it. And within And it's great the way they did this. They basically knew they wanted OLED displays, so they pulled apart Samsung Galaxy 4 phones, and they had their hardware hacker guy make an interface board that lets them drive a pair of Samsung phones directly from a PC on. And then they added this extra circuit to be able to change the persistence globally on it. And you can tap a button while you're going through changing that. And I put on their prototype, and 20 seconds later, you're right. This is absolutely important. I retract any statements that I made about the lack of importance of persistence. It's a compelling thing, but it makes some. So, and there's a couple really interesting things about this. CRTs, back in the old day, had essentially no persistence. I mean, really old CRTs would have long persistence phosphors, but the CRTs that we would use for monitors and gaming had extremely low persistence. The electron beam swept over, and the bright spot was gone in microseconds. Now, when I look around online, there's a class of people that have been really bugged by the transition to LCDs for things like apparently watching sporting events, which is something that I never really do, but the people that really pay attention to watching their Super Bowl game, that a lot of people thought the experience once we moved to flat panels has just been worse than it was on a CRT. And I never understood really what they were talking about until I was able to look at it more from inside out on the head-mounted display perspective. And there's a good example. The problem is, if you're looking at something with a CRT, or most displays now, they're on all the time. It's fully persistent. That was great because there was none of this 60 hertz flickering, eye strain issues. The displays are solid. They look like the reality signs. So it was good for all of these things. But when you have something move, it brings up the fact that instead of like moving smoothly, it's all here and then it's all here. Or worse, when you're tracking something in a head-mounted display, this pixel that's here, and it's going to change to something else, the same pixel gets dragged as you're moving your head, so it smears across this area. And what I originally chalked up to motion blur being crummy LCD switching times, when I would see, like, if you put on a Rift and you move around, you've got these, everything, it can be fine when you're looking at it, but when you move, everything smears and then comes back stable. Now, it certainly is a problem. There's a 20-something millisecond switch on the LCD. But even when you do that with an OLED that switches in a microsecond, you look around and you can't read something as it's moving. And you can do a test of this with any sort of smartphone device. If you've got text on something, you move it up and down, you can totally focus on a line and read it as it's going. But if you're scrolling it, even at a liquid smooth 60 frames per second, scroll fast and try to read there, and you can't do it the same way because you've got this persistence judder that blurs the text going. So it's an important deal. Now, it's questionable how much of a difference it makes for a conventional gaming experience. I did dig back up an old multi-sync monitor that I could run at 120 hertz low persistence, which would be, you'd think, much better than what this demo was. And it still doesn't make that much of a difference to me on standard gameplay. Now, I couldn't sync the demos that I wanted to on there because it was an old square aspect ratio, wouldn't take the other stuff. So I couldn't make a completely fair comparison. And I think that's still a worthwhile thing to do, is go back and dig out the 10-year-old monitor and put your modern best-of-breed graphics engine technology experience and see if you can make it look better. If you can run something at 120 hertz, is that better than looking at or 60 hertz low persistence, looking at an existing display? And I don't know, but for a head-mounted display, it's a world of difference. But one of the fascinating things that comes out of this is one of the other technical directions that might be happening with fully persistent displays that's frustrating that it hasn't is non-isochronous updates, where right now we update 60 times a second, clockwork. And that's why we have vertical tearing or sync tearing when you swap, because you swap in the middle. In a lot of cases, for a lot of displays, what you'd love to do is just say, well, I'll tell you when I'm done. Here's the entire frame. That would mean all of the hot-rodded PCs, it's better to go 62 frames per second than 58. It actually makes a difference, or even 37 versus 35. Any amount that you go better would be an improvement in smoothness. There would be a positive thing to that, and I've thought that could be run in by mobile devices that care so much about power consumption. So that's, and that was in the DVI spec, again, 10 years ago, but it hasn't really come about. It probably will in coming years for mobile stuff, but that's directly in opposition to this low persistence display issues. Because for low persistence display, you're just flashing an image on a regular basis. So you need an isochronous display. It needs to be happening at a particularly relevant regular time period. So there are two directions that both add benefit but are absolutely contradictory to each other, which is going to be interesting to see, kind of see how that plays out. So my hope for this, the other thing with that, with the low persistence, is that 60 hertz is not good enough. 60 hertz was really not good enough even looking at your monitor. On a TV set, when it's a long ways away and it's sort of in your foveal region, it's okay, but it always flickers when it gets out to the outside of your view. I put this in a head-mounted display, and most of it's covering your entire field of view at 60 hertz is completely and utterly unacceptable. I thought that 120 hertz is certainly good enough. Valve's running their stuff at like 95 hertz, which brings up the question that I was lamenting earlier about why can't we have game developers even make 60 hertz games when there's still people looking for 30 hertz, saying, well, now we got to do 90 or 120 hertz. That's going to be a challenge. That's not happening in the real near future. But one of the most exciting technical research things that I did in the last year was this notion of time warping, where you take an image at a particular orientation and rendering, and then you warp it to be rendered for a different position or orientation or time. And that, I'm hoping, is going to be the solution for this, where we finally have a hard real-time situation where 90 or 120 times a second, we absolutely have to deliver a new image, no ifs, ands, or buts, but perhaps that image is coming from a source that's only updated, maybe even only at 30 hertz. So that should allow completely smooth, like mouse look or head look on there for transferring the rotation or even slight movements, but it won't handle anything else in the world. So you've got, if you have your drifting snowflakes in the air, probably won't care if they get a frame here or there and a slight stutter, but if you've got some performance art thing happening in front of you, that may matter. So what might happen is you could imagine taking the reviled motion interpolation technology from consumer television and coupling it with the time warp presentation technology, so your world is always 30 hertz with 1 frame of extra latency there, but you use motion interpolation at an image level, maybe augmented by marking or depth buffers or the things that we can do since we know we create this stuff there rather than interpolating it from an MPEG stream. But you use that to generate 120 frames in between, and then you time warp the presentation so that you have no latency for the actual viewer. So that's something that might actually pan out. So I'm very excited at some of the research opportunities sort of in the next year looking at that, where we might be able to kind of get the best of both worlds, have our cake and eat it too. On the input side of things, we've got, I'm only halfway through my list here. So talk about how touch is so amazingly natural. It is the most natural computer interface we've ever had. And watching kids interact with this is really remarkable. And to think that we had touch screens, we had light pens and things like that for so many years, and it was only until the smartphone and eventually the tablet that this really made its mark. And it's interesting to wonder how many technologies could be like that, where they're niche-y things right now, but 5 years from now they're going to be ubiquitous and kind of the cornerstone of the way we interact with things. Mouse and keyboard are certainly the most precise current thing to be interacting with. You've got the direct relative motion. It's not direct interaction because you're moving your hand and interacting with something there, but it's still highly precise. Game controllers are still, unfortunately, really, really a bad interface for certain types of things because they're not direct interaction. And in the old days, like a gamepad for a Nintendo, a Super Nintendo or Nintendo gamepad was actually not an unoptimal interface because all you did was Mario go right, Mario go left. It's a binary interface. The button was completely reasonable for this. It's only when we started to do turning on game controllers and bringing analog into it that it became a really, really bad thing. It's better than nothing. It's better than binary having an analog on it, but it's not good. You're using this coarse, low-precision muscle in your thumb and time integrating. And you watch people a lot of times playing games, and they're even pulse width modulating with their thumb. Rather than trying to get the exact analog position and and wait the right amount of time. It's like snap, 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 trying to kind of bump your way to the right position. And it's just not good, but it's what we've got to live with there. I think that some of the controllers where you start to see sparks of betterness, I think the PS Move, it's still got kind of a latent, kind of sort of laggy interface to it, but at least you're moving something and you've got buttons. I think the Razer Hydra with the 2 tracked things, it's unfortunate that it's got wires and it doesn't have any feedback inside it, but I think something like that will be where we wind up, where you've got sort of the split thing, you've got 2 hands that can be moved and tracked independently while still having all the buttons to kind of do your intentional actions on it. So I think that things will migrate that way usefully. And then some of the other things like the PS3 gun controller where you've got a tracked gun with a Wii Move and a thumbstick on the end of it, things like that will be really exciting, work. That's a good interface for things. If you had that in sort of a virtual reality environment, that'd be exactly what you wanted there. Again, when you're interacting onto the screen, it's got that layer of separation, so it's not perfect. Right? The tracking is still a hard problem, and it's still remarkable to me that something that seems so fundamental about where is this, where am I, isn't just some nailed down solved problem, but it's not. There's still a ton of research going on. Again, Valve has done some really spectacular work with optical tracking, where you've got things like the Track IR that looks at the little dots and works pretty well in here and then falls apart when you get out of the field of view. You have the RF tracking things like the 6th Sense that work more or less everywhere but are not very accurate and have different fall-off characteristics. There's inside out. I think that my take is that eventually head-mounted displays will wind up tracking with inside-out tracking, where you'll have cameras on them looking out at the world, because that's how the brain tracks, and we should be able to mimic that. But there's a lot of challenges, especially for absolute positioning. I suspect that there's a middle ground between absolute 6 degree of freedom, ground truth, here are the coordinates, that there's a useful intermediate step between just accelerometers and gyros where you have relative positioning to it. And I think that there's potentially benefit for using optical flow analysis coupled with the gyros and accelerometers that are on there to get useful relative motion. But this is all stuff that hopefully can be experimented with and worked on sort of in the coming year. I have not yet tried one of the funny standing platforms where you get to stand on the treadmill rotational stuff. I've talked to some people now that have used it, and nobody has said glowing things about them. But maybe they will yet become something interesting. I'm still most excited for that type of stuff, for taking the sort of indoor laser tag areas and turning those into virtual reality play spaces, which has the advantage of you are completely free to put marker graphics on every wall, floor, and ceiling. So inside-out looking would never be outside, would never not have a marker. I think that's going to be just fabulous when that happens. The audio side of things is, the audio people always feel like the poor stepchildren on the development team, where they get the scraps of the resources given over to them. And we've at least twice before tried sophisticated audio processing, and we just kept coming back to it doesn't win yet in game when you don't know what the speakers are, when you've got the broad range of things there, and you've got a screen sitting in front of people. It's been, maybe it's been the wrong call, but we've looked at it a couple times and it still hasn't really won. But in a head-mounted display, I think it's going to be amazing. I think that having head tracking on it to be able to do that full, the head-related transfer functions, so that you can close your eyes and echolocate inside the rooms essentially. It's going to make an impact there. So I think there's going to finally be some happy audio people that will feel the center of the universe much more than they have in years past. So onto the software side of things now. One of the things that I feel I've probably learned a lot more in the last 3 or 4 years about large-scale software development than anything else. There's been the work that it was an amazing learning experience to go through and take our entire multi-million line code base and get it squeaky clean with code analysis. And that was an experience that I wish I could just sort of download into everybody, because I still run into a lot of people that when you talk about things that are unsafe practices or things that will cause problems, that's such a mushy, nebulous term. It's not like I can count the cycles and show you why my way is better than your way. And I don't know how to win arguments about things like that, but there is wisdom to be gained from looking at those experiences. But getting adoption across everything is still very challenging. And one of the biggest things that we've got in our code base right now is the inertia of the optimization that we had to do for the previous generation. There are a lot of scars involved in getting the 60 hertz gameplay experience that we had for Rage. And a lot of the things that we did there just don't make so much sense now, and extricating them, unfortunately, isn't as easy as just saying, well, we're going to chop this out here and here because there may be something in the model importer that goes into the layout code, that goes into the manifold generation code, that finally comes into the produced baked model loading code. And they were all necessary to get what we wanted to achieve and what we did achieve previously, but they're things that hold us back now that we need to get out of. We need to de-optimize much of the code to make it much more less special cased. Because it's the things that bite you over and over that have assumptions that are in multiple places in the system. But that's where all the really good high payoff systems optimizations are, where you can recognize that, oh, if I do this over here and this over here and this here, I get this synergistic win that you wouldn't have gotten from any one place. But those are also the things that are then harder to dig out of the code base later on. And we have a lot of that in our asset pipeline, the way models are imported, and things that we've tried to do for convenience, tried to do to make things nicer for people. That's one of the big lessons, is accept lenient is just a bad idea. And the web world learned this to billions of dollars of effort expended on that across browser compatibility from accept lenient, where you really want to be a hard ass about the assets that you take in, especially when you control them. You want to say it's either right or it's not right. And if it's not right, just don't allow it. Don't fix it up and let it go with a warning, because nobody will look at the warnings. And that's something that we're still kind of working our way through, where we need to get to the place that in the code we are squeaky clean on all this static analysis. We need to get that way with all of our data assets. We need to be able to say, all right, all of this data, it comes in, we apply lint for models to it and get it squeaky clean, and it's going to be good. It won't cause these other problems. Where right now it's sad how much time we spend chasing problems where something comes in, it's messed up in some way, trying to infer what level of this munging process pipeline made it that way. So simplifying things in that way is one of the big sort of strategic things that we're working on. But in general, this push for robustness first, then predictability, then performance. And we've been our code robustness has been really great with our stable code branch. I think that we've had really high quality software. All of the import pipeline, I did that, I sort of triaged that when I was doing it, because this was millions of lines of code. I concentrated on, okay, here's the stuff that runs. When we ship to millions of people, this is the code that's going to be run millions of times, millions of different platform systems. I did not pay as much attention to the loading code, the tools code, and so we have more problems with that. And we also have the age problem of our tool base still has some of the very first code that I wrote on Windows, all the way back to my first NT workstation was the first editor that I wrote, and there are bits of that. There's still fixed function OpenGL, immediate mode, not fixed function anymore probably, but at least immediate mode OpenGL code in there that that just sets things, and that is far and away the least stable part of our code base. But you get into the question of, well, you don't just stop the world and rewrite everything. We've done a few big initiatives with a couple large-scale changes inside there, but the framework that it's working inside is still this creaky old thing. And actually, one of the things that I spent a lot of time, the first 6 months of this year on, was actually user interface code related to user modability. And I can't talk about it publicly now, but one of the big features that we've got going forward was something that that I went back and wrote UI code for the first time in many, many years, where UI code was always the first thing I pushed off onto the junior programmer, where, all right, it's like you do the menu code and the UI code, and I'll work on this fun stuff. And it seems like I revisit that now every 5 years. Like I did the UI code for the iOS, Wolfenstein Classic and Doom Classic originally, and that was interesting to explore some new things. And it was interesting to kind of come back now that I've been internalize the whole functional programming paradigm and ways to do things there. So it's we're building up new chunks there, but we still have this sort of dangerous no man's land of very old code that's been patched by 30 different people and is problematic. API-wise, we do still have some of the old OpenGL immediate mode code in there. It's gratifying to look around and see that in the larger scheme of things across the world, OpenGL sort of won, which is which really wasn't expected even 5 years ago, where we were kind of thinking